So students, now let's study common base amplifier, and we can write in this we connect an input signal which is to be amplified obviously to the input side of the common base connections of a transistor. Let's discuss it with the help of a circuit diagram. You'll be able to understand it better. This circuit gives you an idea about a common base amplifier. Here you can see there is a common circuit of common base connection biasing of a transistor. Here this is a PNP transistor in which base emitter side is forward biased by a battery VEE. And on this input side, we have connected a small signal EI. Small signal implies the amplitude of the signal is very low compared to this battery, so that this base emitter junction is always forward biased. Now, due to this input signal, emitter current will also fluctuate sinusoidally due to this AC source, and correspondingly collector current will also sinusoidally varies, and it will impact on the output voltage Vout, which is taken across a load resistance connected in the output circuit. And due to the battery VCC, always the collector base junction is forward reverse bias, so that the transistor will operate in its active zone. Here we can see that the output voltage in the circuit we can write as this ICRL, and the variation of this output voltage can be simply given as delta V out will be equals to delta IC multiplied by RL, because the variation in output voltage, that is AC component of the output voltage, will depend on the variation in collector current. Similarly, the input voltage we can consider as the voltage applied across the base emitter junction. And here we can write input voltage as IE multiplied by the input resistance of the transistor, that is RI, or we can simply write as the dynamic resistance of base emitter junction also. And here variation in input voltage can be written as delta IE multiplied by RI. This is the way how we calculate the input applied voltage variation or the AC component, and this is the variation in output voltage corresponding to the variation in input voltage. Here net base emitter voltage can also be given as VBE is equals to, this we can write as VEE plus EI, and here you can see VE is always constant, so variation in input voltage will simply be the AC source which is connected in series with the input circuit, because this is a constant. So input voltage is the AC component or variable component of input voltage is just the variation in voltage of the AC source which is connected here. So if this is the AC voltage variation with time, correspondingly the output voltage will be significantly higher, or we can say we can get an amplified output across the load resistance, because the magnitude of resistance is high, but the variation in collector current will directly be dependent on emitter current, as we already studied that in active region collector current does not depend on the biasing voltages. It mainly depends on the emitter current, which is varying according to the variation in the input source. So this is the phenomena by which we can say that an amplified output we are getting on the output side of common base amplifier, which is corresponding to the input signal connected in the input side of this common base amplifier. Let's continue with some characteristic gain constants for a common base amplifier on the next sheet. Let's discuss various gains in common base amplifier. What you first will study is the AC current gain. We already studied in connections of a transistor about DC current gains, like DC current gain For a common base connection, we can write as alpha DC, or only alpha it is written, which is written as IC over I. It is the ratio of collector current to the ammeter current. And we know it is approximately equal to unity or slightly less than unity. Similar to this, we define AC current gain also, which gives us the ratio of collector current variation to the ammeter current variation. It is written as delta IC over delta IE. This is the characteristic constant we call AC current gain, and it is quite important for various kind of analysis and common base amplifier. And the other gain is AC voltage gain, because mainly as amplifiers are used in amplification of for alternating signals, so we define mainly AC gains for an amplifier, and AC voltage gain is denoted as AV, and it is simply written as the ratio of variation in output voltage to the variation in input voltage. And we already studied that variation in output voltage we can simply write as delta ICRL, and variation in input voltage we have studied, it is written as variation in ammeter current multiplied by the input resistance of the transistor, that is for the base ammeter junction. If we substitute it here, we are getting the AC voltage gain as delta IC over delta IE multiplied by RL over RI. Here we can see that delta IC over delta IE we write as AC current gain. So this AV can be written as AC current gain multiplied by the ratio of output resistance to the input resistance, which is also called as the resistance gain. So specifically we can write that AC voltage gain for a common base amplifier can be written as AC current gain multiplied by this RL over RI, sometimes termed as resistance gain. Resistance gain is not a very useful characteristic. Important as you just need to keep in mind that voltage gain is equal to AC voltage gain is equal to AC current gain multiplied by the ratio of output load resistance to the input resistance. Let's also conclude the section with the third gain, that is AC power gain. Now the last important power gain, AC power gain, is defined for a common base amplifier, is denoted as jEE, which is written as the output AC power to the input AC power, and this can be written as output power we can write as delta IC square RL to delta IE square RI, which is the AC input power, which is corresponding to the variation in collector current and ammeter current. So delta IC or delta IE, we know it is AC current gain. So power gain can be written as alpha AC square multiplied by the resistance gain, or the ratio of output to the input resistance. Here alpha AC multiplied by RL over RI we can write as voltage gain, AC voltage gain. So AC power gain we can write as alpha AC multiplied by AV, where just on the previous sheet we have discussed that AV is equals to alpha AC multiplied by RL over RI, which we are using here. So we can write that in a common base amplifier, AC power gain is equals to AC current gain multiplied by AC voltage gain. Just keep these results in your mind so that in various numerical applications you can apply these results directly.